Hello, this video is an introduction to complex numbers, and it's going to show you where complex numbers come from. Okay, we're going to look at some quadratic equations. Now let's say we have y equals x squared minus 6x plus 8. If we go to graph it on the graphing calculator, which I already typed in here, x squared minus 6x plus 8, and we press graph, we see that the graph crosses the x-axis 2 times. Those are called roots or zeros. And we can factor the quadratic and come up with the roots, or we can use the table of values, but we're going to come up with that it crosses 2 times, so we have 2 real roots. Okay, let's look at this quadratic equation, y equals x squared plus 6x plus 9. And if we graph this one, what we'll see is, when we go to graph it, that it touches. It only has one, well, it has 2 roots, but they're both the same. And that's because when we go to factor this, and we'll set this equal to 0, because we're looking for the zeros, we're going to have x plus 3 times x plus 3. So then x plus 3 equals 0, or x plus 3 equals 0. So then we have x equals negative 3, or x equals negative 3. So we get the same answer twice. I set it equal to 0, that's why we call it the zeros of the function. So on the first problem we had 2 answers. It crossed 2 times. This problem we have 1 answer. Well, it's 2, but they're both the same number. So the graph just kind of bounces off and goes back up. Now we'll look at another example. Okay, now we're going to look at this third example of y equals x squared plus x plus 4. When we try to factor it, we realize we can't factor it, but we can still find the roots by using the calculator. So we turn it on. Okay, here's my equation. When I go to graph this, what we notice is that it doesn't cross the x-axis. So it doesn't have any real roots. There are no real roots to this problem. So we had one that had 2 real roots. We had one with 1 where it bounces, and this one does not cross the x-axis. But we're going to investigate this one a little bit further. Okay, when we go to try to find the roots, we know it's not factorable, so we're going to go ahead and use the quadratic formula, which is that the x value, or the root, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so when we start substituting in our numbers, we have the x value equals negative 1 plus or minus the square root of b squared, which is 1 squared, minus 4 times 1 times 4. And all this is times 2a. So we have that the x value is negative 1 plus or minus the square root of 1 minus, and we have 4 times 1 times 4, which is 16, all over 2. So this tells, what we have here is that the roots are x equals negative 1 plus or minus the square root of negative 15 over 2. And we see that we're trying to take the square root of a negative number. And we can't do that. But we know that the square root of negative 1 is equal to I, which stands for an imaginary number. So we get x equals negative 1 plus or minus I times the square root of 15 over 2. And so we see that when we graphed it on the x and y coordinate plane, it didn't cross, it didn't give us any real roots because our roots are imaginary. And so we're going to look at, in the next video, we're going to look, that's how we come up with our complex numbers. It's because we're taking the square roots of negative numbers to find out where it crosses the x-axis. It doesn't in the real number system. That's why we need the complex number system. Okay, and we'll look at graphing in the next video.